Thank you very much. Okay, so today I want to talk about abuse, or as the title says, if there's free compute, there's abuse, and how we as a cloud computing platform handle or try to handle abusive workloads. So before I go into all of the agent stuff, a bit of background. I'm Jonas. I'm the co-founder of Sliplane. And Sliplane is a European platform as a service company. So we're trying to build the easiest way to deploy Docker containers. You connect your GitHub repository, and then on pushing, you build your Docker image and deploy it on our own infrastructure. And we're trying to make it especially easy for people that have no DevOps experience. And if you combine an easy experience with a free trial, you will attract a lot of abuse. And that is something that we're experiencing right now quite a lot. And that's what I'm trying to solve a bit with agents. So when I talk about abuse, there's really a few categories that are relevant for us right now. And that will, of course, change as time goes on. There's crypto mining, so just people trying to use the trial to mine a tiny bit of crypto. Then there's like illegal VPNs, especially Chinese students that try to go around the Chinese firewall. Then there's like large-scale net scanning, so port scanning, looking for weaknesses somewhere. Then DDoSing, which is incredibly famous among Minecraft servers for some reason. And then the hard ones are spam bots, so like the Telegram, WhatsApp spams, and phishing sites. Now, the first four categories are all relatively easy to catch. So for crypto mining, for example, you just look at the CPU utilization. If it's constantly way above average, it is rather likely that this is like a mining thing. Or for NetScans and DDoS, again, relatively easy. You just look at the network traffic and you can do some pattern matching there. Spam bots and phishing are really hard to catch. And this is what I try to solve with agents, or what I'm still doing. This is like an ongoing battle, basically. And phishing is what I want to talk about today. And this is not just some theoretical thing I want to protect against. This is something very recent that happens all the time. So here, this is something someone tried to host on Sliplane, which is the fake login page of the Armed Forces Division mailing system of Bangladesh. And they basically just try to harvest email credentials of military personnel. And I don't think I need to explain that this is really bad, and we don't want that to happen on our platform. And I can probably already hear you say, like, okay, who would fall for that login page, right? Like, this looks pretty bad. This is the official page. So they are quite close, and I would forgive someone to fall for that phishing attempt. And we are trying to protect against exactly that. And this is something that happens pretty much daily for us at this point, and is really bad for our infrastructure and reputation. Seeing those screenshots, you might think, okay, this is relatively easy to see that this is a phishing attempt, but they are not completely stupid. And there's a few problems in like detecting phishing. So number one is, again, these are developers, right? Like, they know that we're trying to catch them, so they obfuscate everything. When you deploy on Sliplane, you get a subdomain from us that we point to your services, basically. And when you open those domains of the phishing websites, you didn't see anything. You just got this page not found for page, because what they did is they had this code snippet in there, and only if you had this huge random query parameter, then you could actually see the phishing page. So just by looking at the things that they are hosting from the outside isn't really enough in this case. Then the second issue is, obviously, phishing pages are trying very hard to look completely legit. So recently, we had someone build a fake LG, so like the electronics company, web shop. And that web shop looked perfect. Like, it looked just like the web shop of LG. But if you have the context that we are a small hosting company, LG would never host on us. But like, just doing static detection of code doesn't really work here. You need more context. And then finally, because we're growing, the sheer volume of deploys, like manually checking that stuff, is just not an option anymore. We get thousands of deploys every day, and I need to sleep as well at some point. So the solution was to replace me with an army of context-aware agents that are smarter than just like static code detection basically of keywords. And because we have some interesting constraints, we came up with a very simple and also cheap architecture. So when a user triggers a deploy, that could be from a git push or from like a manual clicking, we just let the deploy happen. Because most attacks that we really want to protect against here are not super time sensitive. If a phishing website is live for 5 minutes, it's unlikely that they will have any impact. So we can do everything in the background. We then have a sketchy pre-filter, which is really just like statistical pre-filtering and determining if there's already something that like suggests that there might be abuse. So there's really simple signals, like did they pay their invoices? Because there would never be some scammer that paid hundreds of dollars per month over a year. So you can filter out a lot of people already there. And if we already determine like they're probably not sketchy, we just ignore it completely. And we have a pretty good rate here. So it's like 10x the chance that they will do some abusive stuff if the sketchy pre-filter lets them through. And then we have a threshold. If we can, like the pre-filter things might be sketchy, we give it to the actual agent that then evaluates the code base. And the agent's output will be like a report of what it found, and then a human is still in the loop and makes the final decision. Because we still have too many false positives to just let agents ban users randomly. Especially, again, as we grow, we get bigger customers that like previous versions of our agents thought would be unrealistic for us to have as customers. So, and then we don't want to ban these people automatically. Looking at the agent, we have a very hard constraint here that makes this agent work a bit different, I guess, than a lot of other agents. All models that we use are open source and self-hosted on like rented hardware and with zero data retention. Because I care about data privacy and I don't want to send the code of our customers, especially the normal customers, to, let's say, OpenAI. I'm just not a fan of that. So because we use open source and self-hosted models, they need to be small, and there's a lot of the agent stuff is just workarounds around small models. We start with an in-memory git clone, basically, of the repository and build like a file tree. And then in the first step, let the agent pick, which is in this case, usually a Mistral model, pick what files might be interesting. Because we can't put everything into context. Most repositories are too big for that. So we pre-select files that are probably interesting. We then read those files. And the most important step here is that we do context compacting. Because what we saw that even though like a Mistral model might have like a 128,000 token context window, if you fill that context window up, the quality will go down pretty quickly. So we found like a sweet spot of how much context we can give them, and then we try to compact as much as we can without losing the important information. And then give it together with a rather long system prompt, again, to a Mistral model that then does the actual classification. And in the system prompt, we have some indicators. For example, if there's super strong racism or like racial slurs, there's like a very good signal for phishing websites for some reason. So we put that in there. And then our Mistral model does the actual classification. One interesting thing we found is that the smaller models sometimes just go completely off rails and do some completely different tasks that you never even gave them. So we have some retries built in and then build consensus from multiple classification tries, basically. And that works rather well, because if you try it 5 times, 3 out of 5 will probably be good results. The classification then is just plain text, and it goes through the files basically and looks for suspicious things. This is just a small segment of like the full output. But for example, in this case, it found, okay, it looks like a login page for the government site here. It wrongly guesses the financial department, but that's okay. And then also detects like, okay, there's a query parameter in the URL, which is kind of suspicious, and then comes to the conclusion that it's probably 2 Harvest credentials. The actual report is like 10 times that size. It's way more. So just having that small snippet wouldn't be enough. But it goes through everything and then also has the context of who we are as a company. So we tell them how many customers we have, what kind of customers we have. And just based on that, the agent usually figures out, okay, the government of Bangladesh would never host their mail server on Sliplane. And then suggests, okay, this is probably harvesting credentials. That is pretty much it already of like this very simple agent flow. And to summarize that, and I hope that's something maybe you can also learn something from, is that this whole agent doesn't need to be perfect. It's totally fine if it catches only 80% of the phishing websites, because we just need to be unattractive enough for abuse that they go somewhere else, basically. You can never solve that problem completely and 100%, but if you annoy them long enough, they will just find a different target and leave us alone. So that's really the goal here. Then one thing that we learned pretty quickly is that they also evolve and that red teaming is necessary. So I always try out to jailbreak my own agent. One thing that worked really well in the beginning was just saying, this is an educational phishing site, and then the agents just pass it through. And finding that stuff is pretty basically required, I would say. And then I think that's obvious, but the small models, and especially open source models, are still years behind the commercial things. It would be way easier if you would just use like Gemini Pro. But I think if you put in enough work and also like a lot of working around with your prompts and the context size issues, you can make small models work. Yeah, that was it. If you want to deploy your containers, check out Sliplane. Feel free to connect with me on LinkedIn if you have questions or feedback, especially feedback. I have no idea about LLM stuff. So if you think there's something I can do better, please let me know. Thank you.
Jonas, thank you very much. Very thought-provoking and fun to see. We have one question from the audience. Samantha is asking question, quote, is it actually cheaper if you have to do 3 to 5 models with retries versus using a more expensive model that gets you what you want, perhaps on the first try and more frequently?
I think so, yes. Because the thing is, I'm trying to use models that only fit on one small GPU, and I like 80 gigabytes of VRAM small GPU. And like using bigger models just isn't really an option for me because I would need like way more hardware, and then the costs just explode. So I think it's cheaper. I haven't like benchmarked that.
Yeah.
But I think it's cheaper.
Ravi's adding to Samantha's intuition. He says, also, you end up increasing token count on each retry, right? With that.
The retries are disconnected. So it's just the same. They are not like in the same context. If that makes sense.
Yeah.
Because they sometimes really just go crazy. Like they just spit out complete garbage.
I'm going to put your slides back up for maybe one more question from me, unless folks are going to send them. Can you go back a few slides?
Sure. Where? This one?
Maybe in. Yeah, actually. By the way, it's not just in Bangladesh. I've seen. I mean, this is working very well in our own government here in the US too. So
yeah, and also it wasn't just Bangladesh. It was actually also Pakistan and Nepal that they also targeted. But yeah,
we got an addition from Samantha saying she meant more like regarding third-party models. So like endpoints.
Yeah, I'm really trying not to use third-party. That is maybe not the smartest decision, to be honest. I know there's some companies that do like zero data retention, but I'm really trying to use that for some models. And as long as it's reasonable effort to do that, I will continue to do that.
Nice. Yeah. Okay. Jonas, you have your LinkedIn? Did you post it?
Yes.
I'll put it in the chat as well. Drop it in our private chat, and I'll put it here below for the audience as well. Thank you very much for coming. This was excellent. Best of luck. This is always going to be, I feel, just like a cat and mouse game.
Yeah, it will
probably
be.
for the foreseeable future.
Yes.
Awesome. Jonas, thank you very much.